Hello, everybody, and welcome back to Cork Audio. So, I'm trying something a little bit different now with the camera setup and, of course, the microphone, and hopefully everything, well, knock on wood. I am just going to say, hopefully, I've got all of this straightened out, and maybe I have something that'll work now. This is actually a little bit easier of a setup for me and a little bit easier to record. And, well, it kind of gets my phone out of the way as well, which just seemed to be the biggest freaking issue I was having. But anyway, welcome back. Today is going to be a on the bench type video because, well, I'm working on multiple projects, and, well, that's how my life goes. If I'm only working on one project, I'd hope that somebody would reach out to me and see if I'm okay, because I'm probably not. I kind of function best in my own sort of chaos, working on multiple projects bouncing around at once. So that's what I am doing today. I actually have my 3D printer going. Hopefully that doesn't cause any type of interference or noise in the background, but given the, well, time that I've had with this microphone, I don't think that I should have any type of real issues outside of this directionality of the actual microphone. So, to start off with, today I am looking at a tube amp. This specific tube amp, luckily for this one, I've seen a few of these had some pretty bad failures, but this one is fairly straightforward. It's just kind of the tubes going out on it after a long period of time. But it is kind of focused around something else. One of the main issues that this has is it does have VU meters on the front of the unit, and they are integrated so that you can also set your bias. Of course, they also work for when you're playing music, but there's also a switch to swap it back to be able to actually set your individual bias for each one of the four power tubes on this amplifier. Well, sometimes those switches will get dirty, or they just will not have a good contact because, well, you can sometimes get just some bad quality switches, and unfortunately that is what is the problem with this one. This switch is failing. It has some intermittent issues where it'll actually drop signal whenever it's playing music, but the biggest issue, like I said, is the fact that this is more or less for the integration of the actual bias setting of the amp, so it's easy for a customer to do it. Well, if the meter's not working, that can easily lead to you setting one channel of two power tubes, setting them at the wrong bias. So I think that's what happened with this amplifier, because one side is weaker than the other. Regardless, all the power tubes are kind of worn out. It's been over a year, so I've suggested that they be replaced, so that's what's going to happen. But there are also a couple other things that I look at in things like this that I go ahead and replace while it's here, and I want to go ahead and showcase that as well. So go ahead and turn this amp around, turn my light on, and I'll show you what some of those things are and what I am about to do with this amplifier. Alright, I've got it somewhat set up here. Hopefully you can see it. I'm working, there we go, it's a little bit better. There we go. So, when a tube amp fails, there's a couple things that you need to look out for depending on the circuit, what type of tube you're using, etc. A lot of these amps have some sort of safety circuit built in so that if one of the tubes has an outright failure, that it will protect the rest of the circuit and, of course, trip either a fuse or burn up a resistor, that kind of thing. This particular amplifier actually has PTCs, which are essentially resettable fuses, and they are up here. These two little yellow things here, and there are two more down here. So there are two sides here, and this is part of the bias circuit. So you have one side for your left channel, one side for your right channel. Those two green parts there, those are the bias resistors. So these four components I always replace for a couple of reasons. One, these PTC, which are resettable fuses, these particular models I've looked up, and they are Chinese made only. Now, there are some components that I've tried to find replacements for, and you can only find them through some Chinese manufacturers of semiconductors. But these particular ones I do not like, because I've actually had a few of them. Let me see if I can find one here. in one of these. There we are. So I have replaced a few of these, and sometimes, depending on how bad the failure is, let's see if I can get this in focus. You might be able to see that that little corner is charred there. I've actually had a few of these burn up completely. So I like to replace those with a PTC that I actually know, an actual reputable part number. That way it's just something else safety-wise. I want to make sure that my customers are covered, especially when it's supposed to be a safety circuit. I want to make sure that the safety components are something that I know and can personally stand behind. And like I was saying, I also like to replace these bias resistors, not necessarily because they're bad and because any type that I change it to is going to change the sound in any way. It's just because I don't necessarily like how these are mounted. As I noted, they are bias resistors, so you have current flowing through them. And when you have current flowing through a resistor, that creates heat. And the fact that you have some 10 ohm resistors here, they are flush with that PCB, and if you note this amplifier, this is the bottom of it, so heat rises, that heat is just going directly into that PCB. And I've actually seen at some points with some failures, either these melt the solder and drop them out, or burn a hole through the PCB. So if I can, I go ahead and pull them out so that they are offset from the board, but typically they're cut too short, so I just replace those resistors and give a little bit extra space. And so that's what I'm going to do next. And after that, as I noted, I have to actually take a look at that switch. So this whole board here will have to come out, and that'll help me get access to this actual switch back behind here that allows me to switch between the bias and the regular VU meter function of these front meters. So I have to take a look at that switch. So that's what I'm going to do next. Go ahead and remove all of this and go ahead and get started on that. So as I had noted earlier, I was trying to sound confident that I had everything figured out, but well, now maybe I do, as I have figured out how to get audio on both channels. So enjoy that for the rest of the video. But as I was noting, the main issue for this specific amplifier was the fact that this switch needed rebuilt. And I just rebuilt the switch because it's easier for me to do that than to actually replace this said switch. Because as you can see, it is on its own PCB here, and this PCB is actually a multi-sided board. It has two sides, which means it has actual circuitry on both sides of it. And why that is an issue for a switch like this is because when you have a multi-sided board and you connect multi-layers of conductors together, that is usually done through something called a via, which is essentially just a copper sleeve pushed through this actual PCB, and then that switch is shoved through all those vias, and then it is typically wave soldered, as you can see here. The problem with that is, as I said, those vias, they're copper sleeves, so of course whenever you heat solder up or heat up a pin, that's going to cause some sort of thermal expansion, and well, it's already a pretty close snug fit before they get soldered in. So even if you were to go ahead and clean all the solder off, get rid of all that stuff, and try pulling this switch out, you're still going to have a heck of a time if you're going to be able to. And the last time I was actually able to do so, even after letting it cool, everything else, I still ended up having to do some trace work because it ended up pulling out one or two of those vias. So I've had a lot better luck just rebuilding the switch. So that's what I'm going to go ahead and do. This is the main portion here. This is the internal actual rocker. If you can see a little bit there on the base, there are two nodules because this is a double pole single throw switch. So it has two rows of conductors in there, and then it has these little metal pieces that are supposed to rock back and forth between position 1 or position 2, and sometimes these are just flat or they are too bent, and it just does not make a good connection. So that's what I make sure, that they're both evenly bent as they should be, making good connection there. Clean all that nasty lubricant out, put some actual decent dielectric in there, and put the switch back together. So that's what I'm going to do before taking a look at this actual amplifier board here that I was talking about earlier. Alright, so we got that switch back together. Now, I just want to go ahead and note that this isn't something that I would recommend for everybody. Like I said, it's just easier for me to do this way because, well, it works better longevity-wise. I don't have to worry about spending extra time trying to repair this PCB. And, well, when you know how to do it properly, sometimes it can work just as well as a new switch. But I just want to make sure that everyone knows the risks, that, or at least that you think about the risks before doing something like that. Consider how much current you have going through it, any type of failure modes that you could deal with. Of course, the fact that I opened this up, so now it is, of course, a little bit more susceptible to moisture, but I use a specific way of opening this so that I don't actually bend that metal, and it creates the same type of seal as it did from the factory. And I also ensure that I treat the inside properly. I use contact enhancer on the actual metal portions throughout, and then an actual dielectric grease such as this Deoxit L260D inside of it, and go ahead and work it through there. It looks like what they were using before was some sort of white lithium grease, which just is nasty. So now that I have it all back together is the moment of truth to see if it works. So I'm going to go ahead and put the mic down and get this set up to do a test. So if we hear a beep, that means that it is working properly. Oh. Come on now. So we're set up on continuity, so you should hear that. There's a little bit of crud on there on the bottom side, but I have continuity. Go swap position. Come on. There we go. Good. Swap it back. Just a whole bunch of mess underneath of here that I'll probably clean off with some isopropyl alcohol, but the switch is working, so that's a good sign. And I'll get this cleaned up, get it back in, and I can focus on the next section of the amp. Oh. Now that I've got the switch back in, I like to go ahead and take care of some other things while I have this extra space inside the chassis before I actually start work on this PCB. Also because I like to make sure that some things have time to either set, dry, or to set or dry before I actually put electricity back through it. So, taking a look at this, there's a couple things that I note. And I also wanted to point out that this is a repair. It's not a modification. This isn't a custom build type thing. And as much as I would like to actually do everything the Angela Gilbert way, you know, have things done the right way, it's not always one of those jobs. Sometimes it's just a job to get it back to the customer, get it back to working condition, and that's what this is. But that being said, there are some things that I still take a look at because I want to make sure that this is going to have some sort of longevity for the customer. And if there's anything that I can do easily that's not going to take me a bunch of time, that will actually, you know, something that I wouldn't have to actually pass the cost on to the customer, that I can just readily do to make it better, I will. So There's some things that I'll take care of, such as some wire routing, such as this right here. This is actually, well, you actually see a bad connector there as well, but I go through, I check all of these connections. They are all type of a crimp connection, so I make sure that they all have a nice firm grip on the actual standoffs from the board. As I was noting, this is actually the left and right channel and ground for the audio, and as you can see from the factory, it is just bound here with the actual heater. Well, the problem with that is this heater is just AC, so we have AC wire coupled directly to this actual audio wire. So I like to go ahead and cut that, separate those. I go ahead and twist the left and right together and then wrap the ground around it to try and get a little bit of EMI rejection to help with some noise from that. I also note some other issues. Every now and then you'll have some issues from the factory where they'll forget to put in a component or something, and in this one I actually note there are two 1 million ohm resistors that are supposed to go from left and right to ground here in the volume, so those will be replaced, and that should help with some noise as well. So I'm going to go ahead and take care of that, and I'll also use some silicone in here to help with some damping and just to help with rigidity, because we have our big power supply capacitors here and they're just dangling from the actual solder connections on the PCB. So I'm going to go ahead and put some nice silicone here and here. That way everything's bound together and attached to the board a little bit better. And that'll give some time for the silicone to set, for this switch to dry, while I'm working on this board. Alright, so here we are with the actual board outside of the entire chassis. And as I noted on this one, it has not had a catastrophic tube failure, but it's still something that I like to replace even when I have not had one, just to make sure that this amp is going to, well, essentially not come back to me. The circuit as it is actually has protection in it for when a tube fails, but with some of the components that I've seen used or just how they have been implemented, sometimes that has been the actual cause of the problem. So one of those specifically is being these PTC resettable fuses here. So these I've only been able to find a part number on one website. Of course, they originate in China, and as I've said, I've had some issues with these. I don't trust them, so I actually have some PTC on hand from a reputable supplier that I replace those with no matter what. And then, as I noted, these bias resistors here, they're just some 10 ohm resistors, but they're right there up against that PCB. So if you have a lot of heat being dissipated through these, especially in a failure condition, sometimes that solder can actually end up melting, the whole resistor drops out, or it actually creates enough heat to where it can create a hole in the PCB. So I'm going to go ahead and desolder all those, replace those, put some new resistors in that have a little bit of space for that heat dissipation, especially since the board sits in this configuration where it's just heat going up into the board. Coming around to this side, we actually see that there are some paths here. That's just part of the board itself, but because they did some sort of wave soldering with it, you could see in some parts the solder stuck, some parts it didn't. It just kind of looks bad, and that's something else that I go ahead and correct. I smooth all that out, add a little bit more solder, and that's something else I do just to make sure nothing can cause a failure, because if you have just like maybe a little piece of solder or something here and it gets shipped back, I mean, this is a 50-pound amplifier, that getting shipped around, you have some vibrations, knock off some solder, next thing you know, you could end up shorting something somewhere, and it's just something that, you know, it's here already. Go ahead and fix it and do it the right way. That way it doesn't come back to me. So also checking in the bias circuit are the switches, because this is how you switch between the two tubes. Make sure that that has good contact, because sometimes those will get burned out. And then of course these little attenuators. This is actually how you adjust that bias. So I go ahead and make sure that all of those feel good. I measure them, make sure that they are not burnt out. And once that's all said and done, then I just go ahead and clean it, and this board will be ready to go back in. So I'm going to go ahead and get that done. Alright, so here we are a little while later, and quite a bit of work later. There's a little bit more solder work than I anticipated, but that is done, and we are about to go ahead and put this back inside the unit. So as you can see now, we have new bias resistors, the new PTC, which you can see they even have a larger physical size. The bias resistors actually have some spacing off of the board now. And another thing that I did is I went ahead and reflowed every single point on these tube connections, all of them, because I had found a few cold solder joints. So at some point, whenever you find enough of them, it's just easier just to go ahead and go through it all, make sure that it is all said and done, good to go. And I showed you a little bit of the traces there that had been just had some nastiness left over from the solder bath. All that's cleaned up, and nice new solder throughout there. And yeah, as I said, everything is good to go here now. So I'm going to go ahead and replace this back into the amplifier. Finally, we have everything back together here. As you can see, I went ahead and put the silicone back here on the back power supply, made sure everything is routed properly. I was mistaken earlier, this is not the signal, this is actually the positive and negative rails of the power supply, but I still like to keep that away from the actual AC because you go through so much trouble of trying to filter that DC with the use of the choke coil and of course the actual filtration in the power supply itself. Doesn't make much sense to bind it right next to a completely unfiltered, directly off the tap AC source. Other sources of AC I can't do too much with without some heavy modifications, and like I said, that's not one of those things. Signal comes around here. I got it going up against the ground plane. As I noted, I had a couple of 1 million ohm resistors that were missing here on the volume attenuator. That is now remedied. All the solder joints for the tubes have been reflowed. New bias resistors, new PTCs to protect those circuits. And I do believe we are ready to go ahead and put the lid on it, put some tubes in it, and start testing. Here we have all of the tubes back into the unit. Everything's back together as it should be. As you can see, I have the tubes labeled that way in case I have a sort of failure anywhere inside the circuit, or if I have to actually take these tubes out when I do a final cleaning of this unit, I actually know how to just put them right back in and not have to worry about setting the bias again. So that's what I'm about to do. Like I said, I already went and put all the tubes in. Whenever you put tubes back in, always make sure that you're putting them in the right locations. Like these front 3 tubes, you'd think that they're all preamp tubes. Only one, the center, is the actual preamp tube. These just kind of help split that signal for the push-pull of the actual power tubes. So make sure you have the right tubes in the right locations. In this specific setting, it's the 12AX7 in the center with 2 12AU7s on the other side. So, of course, make sure you take the foam off. I always make sure everything is in the proper setting that I want it to be. Cycle the power switch while it is off and not plugged in. This is a tube amp, so of course you cannot turn something like this on without some sort of load on the actual outputs. So I actually have 2 8 ohm 20 watt non-inductive loads just attached to the back here, just some small specific resistors. For this case, I actually have a dummy load off to the side, but I only do that when I'm only connect to that when I'm doing, you know, larger wattage type amplifiers, or specifically for something like this, if I was doing, well, I'm going to do a 3-day burn-in testing over this, so that's when I'll connect it to that. But just for setting bias and testing everything, those small ones will do fine. So we have IEC connection. We'll go ahead. There we go. Turn the light off. Everything's where it should be. Bias is at the lowest setting. We're going to let it warm up for 3 to 5 minutes before actually setting it. It's tubes, so it actually creates the power through thermoionic emission. I hope I pronounced that right. But you need actual heat inside the tubes for that to work, and that's why you have those heaters. So don't set your bias until they're actually up to temperature. So this actually has an LED in front that flashes as it is slowly starting. The click just went in, so the relay clicked in and the amp is fully on. So now I'm going to go ahead and wait for a few minutes, let this warm up, and then I'm going to go ahead and set that bias. So if you can see if this will focus, it doesn't like to in this particular light, but we have bouncing of the meters. It's been over 5 minutes, and I went ahead and set the bias on this. It's been playing for a little bit, warming up more, so I'm going to go ahead and test the stability of that. So this is that switch that I rebuilt, the meter switch. Turned the volume all the way down, swapped it to bias. And now I just have to switch these up top to check the bias. They're still looking good. Typically for this one, there's a little red section with 3 marks. You want to plant it in the center for this specific amplifier for how it is set up. But I like to go a little bit more, well, a little bit less bias current, and I set it at 0 on these actual meters because, well, there's nothing wrong with having a little bit less bias to preserve your tubes a little bit longer. At least this specific amp makes it easy for a customer to set their own bias for tubes because, as I said, you just flip it down to the bias there, and then you have your switches for each individual tube, and you just go ahead and hold that switch down and you adjust it with those attenuators there. You need a special tool, of course, something like this to be able to do that. But that is done. It is working. Swap the switch back, and no issues at all with the VU meter, so that's a good sign. So I'm going to go ahead and let this play for a little bit longer for tonight before shutting it down. It'll still have at least 2 more days of testing on it. Tube amps I do a little bit more for testing and work just because of how big, heavy, expensive they are and how difficult it is to get here. This specific one is 50 pounds, so you can imagine how expensive that is shipping it across the country to have your tech look at it. So I like to go a little bit above and beyond to ensure that it doesn't come back to me unless it's going to be something that's an upgrade type thing. So that is the repair on this unit. So thank you for following along on this special On the Bench session. I just kind of wanted to showcase one of the things that I work on in a typical day. I still have other things that I am working on and other projects that I have to still get done as it goes into the evening. But at least this is performing well and should be able to go back home to its owner next week after testing has been completed. I won't be doing any type of special editing for a while until I can at least get my basic cinematography done and figured out. So hopefully this video turns out a little bit better than how a couple of my previous have. So thank you for following along, and I also wanted to showcase something else that I had off to the side here. I've got, like I said, I've been working on all kinds of things, and there's some other things off to the side that I've shared with friends that you might see a couple things in prototypes that I'm working on. But here is one that I will showcase to you. This is about to be one of my prototypes, And this is just built out of a bunch of components that I have just laying around. And that's kind of one of where my ideas had come from, such as this transformer was something that I scavenged out of, I believe, what was this one? I think this was a Scott receiver, like something like a 30 watt per channel Scott receiver or something like that. And it just happens to be around the right amperage and voltage that I need for a specific amplifier type design. And I also have all of these capacitors. These, well, they're not good. They're old capacitors. These are actually the ones that I took out of the BC2 and recently replaced in that power supply. They all measure terribly. They're supposed to be 4,700 microfarad, and this specific one measured at 3,991. Absolutely terrible. But it still holds a charge, and there's at least enough here for me to at least experiment. As long as I do a slow enough startup and a slow enough turn off, it should still work okay to at least have a proof of concept. And it's just something that it's not going to cost me anything. Like I said, it's just stuff I had laying around. You could probably already see I've got a rectifier attached on here with silicone and an extra heatsink. But that's something I look forward to sharing with you. Like I said, there's a few things I'm working on. Another prototype being printed on the 3D printer. I've got another prototype over my shoulder here. I'm looking forward to unveiling quite a few of these and some other big things. My next video will probably be one of those big things, a big move. So be sure to tag along for that next video, but for now, like I said, I still got some things to do, and it's getting on into the evening. So thank you for tagging along on this On the Bench session. I plan to do many more, and thanks for watching. I'll see you in the next video.